What do Krafle, Mutnovskaya, or Arkai all have in common? Well, they are all hard to say, but that's not the answer. The answer is that they are all close to fault lines, and more importantly to us, they are all geothermal energy sites. Geothermal is a mature, renewable technology that has been used commercially for over 100 years. It can be used for direct heating or electricity generation and is used for baseload power in more than 24 countries. Geothermal energy should be able to achieve competitive, levelized costs of electricity, but sadly its use is limited because of the lack of availability of high-quality resources. In 2014, geothermal energy produced just 0.3% of the world's electricity and heat. This means that it contributed 77 terawatt-hours of electricity and 75 terawatt-hours of heat. In this diagram, with capacity on the y-axis and country along the x-axis, you can see the distribution of installed geothermal electricity generation capacity by country. It shows the United States of America has the largest installed capacity. The power station at Krafla in Iceland is an example of geothermal power and consists of two 30 megawatt turbines turned by high and low pressure steam from drilled wells. The use of geothermal energy for heating is quite site specific and so has only been adopted in a few countries like China, Turkey, New Zealand, Japan and Iceland. The heat can be used for district heating or in industrial settings. Direct use of geothermal energy is more practical when the temperature required for the application is close to the temperature of the geothermal resource. Industrial uses of geothermal energy include drying of forest products, steam generation, warming of ponds for aquaculture, and de-icing and melting of snow. The Ecogy project in eastern France, completed in 2016, is another example of direct use of geothermal energy. In an enhanced geothermal system, water is brought up from 2,500 meters below ground and used to make steam for a starch manufacturing plant. The geothermal source meets 25% of the Ecogy plant's energy needs and replaces about 16,000 tons of oil equivalent of fossil fuels. There has been a significant increase in the use of geothermal energy for heat in the last 15 years due to the fluctuations in the price of fossil fuels and the need to replace them with a renewable resource. Sadly though, there are only a limited number of high-grade geothermal resources and there are technical and economic barriers to the use of low-grade resources. Interestingly, the amount of heat a geothermal resource can deliver is limited by the rate at which heat can move through rocks and replenish what we remove. So the source may start as a hot, high-quality resource, but if you don't use the heat in a sustainable manner, eventually the resource will start to cool, lowering the temperature and making the resource less and less useful. While there have been many developments in geothermal resources worldwide, there are still barriers to geothermal to reaching its full capacity in climate change mitigation. The technical barriers include large distances between electricity markets or centres of heat demand and the geothermal resource, and a lack of transmission infrastructure to geothermal sites. A lack of expertise in geothermal drilling and reservoir management also means that some countries struggle to develop their resources effectively. Successful development of geothermal energy requires not only good resources, but also coordinated policies, regulations, incentives, and initiatives. For example, Kenya's Olkaria 4 geothermal plant with a capacity of 280 megawatts is the largest single-site geothermal plant. It was commissioned over 2014 and 2015 and is part of Kenya's strategy to further develop its geothermal resources, receiving incentives to support development. However, not all geothermal resources are successfully commercialized even with the support of government policies, incentives, and with geothermal resource development expertise. In Australia, for example, there are geothermal resources, but they are remote and difficult to take advantage. To date, very few trials have been viable. A trial was undertaken at the promising site of Inaminka, South Australia, near the border with New South Wales. But the cost of the technology, combined with the cost of delivering the electricity from the remote site to the market, was ultimately too high. So the world's potential for geothermal energy generation remains far from exhausted. However, while further uptake of geothermal systems is expected to increase, geothermal energy only offers an alternative to countries that have the natural resources that can be developed at a competitive price.